Hi, my name's Hannah Bloomfield, and I'm here to talk to you about some of our current work at the University of Reading, quantifying the sensitivity of European power systems to energy scenarios and climate change projections. So we know that climate is changing and that climate simulations consistently show an increase in European near-surface temperatures, which is very robust across all the models. Although changes in near-surface wind speeds and irradiance and precipitation differ between the models, and these changes are accompanied by large amounts of year-to-year variability, sometimes larger than the signal due to climate change. These factors make it quite difficult to estimate the impacts of physical climate change on power system planning. So what we've looked at here is how does climate system uncertainty compare to energy scenario choice? And what could that mean for energy system uncertainty in general? So to do this, we've used data from the European Climate Energy Mixes project, also known as ECEM. The data is available from a demonstrator, a link to which is at the bottom. The data we've used in this study is from 7 different climate models, where there's country-level simulations available as time series from 1980 through to 2065. So we've got 7 different climate models and 2 different climate scenarios to understand the impact of climate change. We've also got 5 different energy scenarios from the eHighways 2050 project to understand the impact of energy policy choice. So if we are just to plot all of this data out, the first thing we notice is that future power system uncertainty is hugely dominated by the energy policy choice. The sets of coloured lines here are all related to, they're coloured by energy scenario choice. So all of the climate simulations sit within these colours. But this doesn't mean that climate uncertainty isn't important. It just means that there's a wide range of energy policy options we can choose at present. So once a policy choice is made, so if we pick one of the scenarios above, the impacts of climate change can be seen more clearly. So in doing this, if we look out to 2050, by looking at the percentage change between the average of 20 years centred on that period and a present day, we see like the national power systems may be subjected to considerable impacts from climate change. This is particularly clear in demand. However, for wind and solar generation, this is particularly sensitive to the choice of climate model, with different models showing a very different response in the figure. And also the years of data used to compute the results are very important. So these results show that climate plays a big part within energy systems future planning, and more thorough consideration of climate uncertainty is therefore going to be needed in the future. So thank you for listening. Any questions, please do get in touch.